In this lesson, you will learn how to simplify radicals. We will do a process of rationalizing the denominator because there's a rule that you cannot have irrational numbers in the denominator of a fraction. So these next examples will show you how to rationalize the denominator. Let's look at our first one. We have the square root of 5 over 6. Our first step is to rewrite that with the square root of 5 over the square root of 6. So right away we see the denominator is an irrational number. We must rationalize the denominator in order to get rid of that square root symbol in the denominator. In order to do that, we will multiply by the square root of 6 over the square root of 6. Notice that this is just really a value of 1. Dividing a number by itself really just equals 1. And multiplying that problem by 1 does not really change the value. If I multiply your age times 1, I've not changed how old you are. So in this problem, when we multiply by 1, we're not changing the value of the original problem. We're just maybe changing how the problem looks. So 5 times 6 gives us a square root of 30. 6 times 6 gives us the square root of 36, and that is a perfect square. So in the denominator, the square root of 36 is 6. We've already gotten rid of that radical sign by rationalizing the denominator. In the numerator, we need to check to see if we can simplify the square root of 30. So do your prime factorization. A prime number can go into 30 is 2, and that gives us a 15. We can divide by another prime is 3, gives us a 5. And finally divide by 5 gives us a 1. Notice there are no pairs of like factors, so the square root of 30 cannot be simplified. It will stay the square root of 30 in the numerator. Notice that is as far as we're able to go. The square root of 30 divided by 6 cannot be simplified any further. Do not divide 30 by 6 because that's not really a 30. That's the square root of 30, which is very different. You can check these in the calculator, typing in the square root of 5 over 6, so you can go alpha y equals to get your fraction. So do 5 over 6, whatever that crazy decimal is. You don't have to write it down because we're simplifying, not just finding the value. So then type in the square root of 30 over 6. So do alpha y equals to get your fraction, the square root of 30 divided by 6. And notice that those values match, so you can feel confident that you have simplified correctly. Let's look at our next example, number 6. Here we have the square root of 6 over 15. So our first step is to rewrite it as our numerator divided by our denominator. But while you do that, always check to see if you can reduce the fraction as you rewrite it as the numerator and denominator. 6 and 15 can be reduced. They're both divisible by 3. So 6 divided by 3 is 2. 15 divided by 3 is 5. This helps just work with smaller numbers as you're going through the problem. So here we have the square root of 2 over the square root of 5 after we've reduced our fraction. We will then multiply by the square root of 5 over the square root of 5. And we know to do that because of what it's called, rationalizing the denominator. It's the denominator that we care about. It cannot be an irrational number, so that's why we're rationalizing the denominator to get rid of that radical sign. So in the numerator, 2 times 5 is 10, so we get the square root of 10 over the denominator is 5 times 5, which is 25. The square root of 25 is a perfect square, so that gives us 5. The square root of 10, we'll need to do our prime factorization, so 2 can go into 10, gives us a 5. 5 can go into itself and gives us a 1. Notice we have no pairs of like factors here, so the square root of 10 will stay in the numerator. That's as far as we can go with our answer because the square root of 10 divided by 5 cannot be reduced. It does not equal 2 or the square root of 2 because this is not a 10. You cannot divide those numbers. This is the square root of 10, which is very different. Once again, you can check your beginning problem and your ending answer to see if they're equivalent, to see if you simplified and made them still equal throughout the entire problem. Let's look at our next example, number 7. We have the square root of 24 over 27. Square root of 24 over 27. Again, in your first step, as you're rewriting your numerator and denominator in its own radical sign, also see if you can reduce. If you're not sure, go to your graphing calculator and do alpha y equals and choose that fraction option and type in the fraction. So 24 over 27, it does reduce to 8 over 9. So if you're ever unsure if a fraction can reduce, use that alpha y equals feature to help reduce your fraction. So we get the square root of 8 over the square root of 9. You can reduce 24 and 27 by 3 to get this fraction. So notice here we're going to multiply by the square root of 9 over the square root of 9. Again, choosing the value from the denominator and multiplying by something that equals 1 using that denominator value. 8 times 9 is 72. Again, keeping that radical sign because you've not used that yet. 9 times 9 is 81. Again, keeping the square root symbol because you've not used that square root just yet. So keeping those numbers in that radical. We do know the square root of the square root of 81 is 9 because we just made that perfect square by choosing the square root of 9 to multiply by. So whatever you choose to multiply by is what it should equal once you take the square root. So the square root of 81 equals that 9, which is what we chose. We do need to check the 72 by doing our prime factorization. So go off to the side, and 72 divided by a prime, we'll start with 2. Gives us a 36. We can divide by 2. That gives us 18. Divide by another 2 gives us a 9. Continuing to divide by primes, now I'll have to go with a 3 and another 3. Again, always check 2 times 2 times 2, or really 2 to the third, which is 8, times 3 times 3. All of that multiplied back together should give us 72, and it will. So these are the prime factors of 72. Because we have a square root symbol here, remember the understood index number is a 2. If you need to write that in, you can. So we're going to be looking for pairs of like factors. So we have a pair of 2's and we have a pair of 3's. So on the outside of the radical, we'll have a 2 times a 3. We'll have a 2 times a 3 because of this pair of 2's comes out as a 2 and this pair of 3's comes out as a 3. The 2 that did not have a partner or a pair to be with has to stay inside the radical. So the square root of 2, this one here, has to stay inside the radical because it did not have a partner or a pair to go outside with. So 2 times 3 is 6. The square root of 2 over 9. Always we need to reduce our fraction. So ask yourself if there's a number that can go into 6 and 9 to reduce. Again, if you're not sure, use the alpha y equals feature of your calculator to help you reduce. It can be reduced by 3. So 3 goes into 6 twice. We'll keep the square root of 2. And 3 goes into 9 3 times. So there's our final answer, 2 the square root of 2 over 3. That should be equivalent to the square root of 24 over 27. So let's check that. We can go alpha y equals, choose that first option. We should have done our radical sign first. Let's clear that out. So the square root of alpha y equals, there's our fraction, 24 over 27. That should be equivalent to, now let's start with our fraction, 2 the square root of 2 in our numerator and 3 in the denominator. We do see those values are equivalent. So we can assume that we have reduced correctly. If ever those are not equivalent, go back through your work and see from one step to another, where did you lose it and it's no longer equal, because each step should equal the next. Let's look at one more example. Number 8. Really, this is going to be the same example as number 7. I just want to point out something to you that you'll want to pay attention to because it may happen and save you some steps. So we've got the square root of 24 over the square root of 27. Again, the first step can be reducing. That always helps save some work by working with working with smaller numbers when it's acceptable to reduce. It does help work with those smaller numbers. At this point, notice in the denominator, 9, it is already a perfect square. So in the last example, we went through the process of making it a perfect square. It was a much larger perfect square in order to rationalize the denominator. But because we already have a perfect square, the square root of 9 is 3. Notice right away that radical sign is gone. So really all we have to do is simplify the 8 to see if we have any prime factors that have pairs. So 8 can be divided by 2, 4 can be divided by 2, and of course 2 can be divided by itself. So we do have a pair of 2's that gets written on the outside. The 2 that did not have a pair stays inside the radical. And notice we're at the final answer in a lot fewer steps because we recognize not only could we reduce the problem, but we already had a perfect square in the denominator. We didn't have to go through the process of rationalizing the denominator.